Right here I have a table set up to solve this problem number 8. It's just a different method. If you are not sure whether to do the heartbeat or the boomerang, you could set up this table. And what this table does is it divides the image into the 3 similar triangles, and it sets up proportions with the 3 inside of this triangle so that you can solve it using proportions and not necessarily thinking about the geometric mean theorems. So to set up this table, I like to go small to large. So I got short leg, long leg, and then the hypotenuse, which is the longest side of all. Then I have my small triangle, medium triangle, and the largest triangle in the image. So the small triangle is this one on the left side here. And so I'm going to put its pieces in this top row. There is a side missing, and I like to look at the picture and see, could I find that side? And since it's, if I look at just the large triangle, I see that the hypotenuse is 16 and that the leg is 14, and I can solve for the missing side by Pythagorean theorem. So I know that 14 squared plus the side I'm missing would equal to 16 squared. And so x squared will equal 60 if I did 16 squared minus 14 squared. And then when I square root 60, I get 2 root 15 because it divides by 4 and 15, so that gives me 2 root 15. So I'm going to put 2 root 15 on that side. So for the small triangle, the short leg is y, the long leg is z. It's always that inside part being the long leg of the small triangle. And then the hypotenuse is 2 root 15. In the medium triangle, which is this one right here, the short leg is z, the long leg is x, and the hypotenuse is 14. And then in the overall triangle, the largest triangle here, the short leg is the hypotenuse of the small triangle. The long leg is the hypotenuse of the medium triangle, and then the hypotenuse here is 16. So the table creates proportions that you can use and solve with to find the missing pieces of the triangle. So I got rid of my highlighting so I can show you where I'm going to use to solve. You can set up any proportion in here as long as you're using the same 2 triangles and the same 2 like leg pieces. So the ones that are my favorites are like this top set of 4. That's a very good one. We can do the bottom set of 4. That one I will use. We can do the 4 corners, like bingo, kind of. Those are good to use. You could also do, you know, like these 2 and these 2 even would be helpful for finding z, if you notice that, because it's both the medium and the large triangle, and it's a short leg over short leg, hypotenuse over hypotenuse. So you could set up a lot of different proportions here for your solving. The one that I'm going to use first is this one to solve for x. So I'm going to put x over 14, 14 over 16. Now I already know, because I've already worked this problem out, I know that it's going to be weird fractions or decimal answers, and since I'm going to need to use x to find z and z to find y, for right now we're going to go and we're going to assume that the directions had said to like round to the nearest 100th place. So that's how I'm going to work these, is to the nearest 100th. Of course you want to do whatever they're telling you to do as far as your rounding. 14 times 14 is 196. Dividing by 16, x is 12.25. So now we know x. So now we can find, let's find y. I'm going to use the 4 corners to find y. So I'm going to use y, 2 root 15, 2 root 15, and 16 there. And so 16y, 2 root 15 times 2 root 15. And so the way that you multiply these together, the 2 times the 2 is a 4, root 15 times root 15 is just 15 because, that buddies up to get out of that house there. So 16y on the left side, so there's 16y, 4 times 15 is 60, and so y ends up being 3.75. So 3.75 there for y. And now I'm going to use the upper left corner there to find z using the 3.75 over z equals z over 12.25. And so 3.75 times 12.25 and z times z. And then when you square root both sides, you get approximately 6.78 for z. Now we have x, y, and z for the problem. All three of the missing pieces. So you can use this table method for any of the pictures that you're given. If you don't have a lot of information on the image though, like these up here, what you would have is a lot of things would be blank in the table, and so you would just fill in what you could and not fill in the whole thing. But then you would still be able to set up a proportion and solve.